Hey everyone, this is Math 103 and we're working on section 2.1 today on evaluating variable expressions. Many quantities in fields such as business and science can be found using variable expressions. These expressions, they represent known relationships between various quantities. And once we find out the values of the variables, we can plug them into the expression and determine the value of the quantity we're looking for. So let's look at a couple of examples. First example, the owner of a food stand is selling fresh baked pretzels at $2.50 and soda pop at $1.25. So at the end of the day, the owner figures out how many of each item they sold, wants to calculate the total revenue, which is the income. And the other example from chemistry lab, a student is studying a sample of krypton gas at a certain pressure. How many moles of the gas are in the container? So these are some examples of some of the things we can calculate. So our objectives today, we want to evaluate algebraic expressions given values for their variables. So we're going to be plugging the values in and then using order of operations that we learned before to find the value. We'll start off with some vocabulary. So I'll look at this expression here. This is called a variable expression because it's an algebraic expression that contains variables. A constant, fixed, unchanging number. So the constant in this expression would be the number without a variable part next to it. So it would be -9. Make sure you include the sign. A variable, it's a symbol that represents an unknown quantity. So x and y would be the variables. A term. A term is a collection of numbers and variables separated by addition, subtraction, or the equal sign. So one of them is 2x. There's a term. 4y is also a term. And then keeping the sign with it, -9 is also a term. This will be important later when we're doing distribution, where you have to multiply a number by each term, so make sure you can identify what a term is. The variable part, the collection of one or more variables and their exponents in a term. So the variable part of this term, 2x, would be x. And the variable part of this term, 4y, would be y. And the constant term, it doesn't have a variable part. A variable term made up of a constant and a variable part. So here's a variable term, here's a variable term. This is not a variable term. This is called the constant term. Coefficient, number in a term. So coefficient in the first term is 2. Coefficient in the second term is 4. Algebraic expression, that's the entire collection of constants and variables and operations. So 2x plus 4y minus 9 is a variable expression. Evaluate to find the value of an expression. So if we knew the values of x and y, we could plug them in and find the value. So let's practice identifying some of these parts. We're going to name the terms of the variable expression and identify the constant term. -12 plus 5x squared minus 3x. So we have three terms. We have -12 as a term, 5x squared as a term, and -3x is a term. Now the constant term is -12, and the other two would be variable terms. Your turn, number 1. Name the terms of the variable expression and identify the constant term of 6x plus 9 minus 5 x to the third power. The terms here, we got 6x, 9, and -5x to the third power. And the constant term is +9. Now in the next one, we're going to name the variable terms in the expression, and then we're going to identify the variable parts and the coefficients. All right, so there are two variable terms in this expression. There's 3x squared y and negative 4x squared y to the fourth. 7x is a constant term, so that's not a variable term. Now we're going to identify the coefficients of the variable parts. So the coefficients are the numbers. So coefficients would be 3, and keeping the sign with it, negative 4. And the variable parts are x squared y, it's the entire collection of variables and exponents, so x squared y here, and the variable part here is x squared y to the fourth. Your turn number 2. So our two variable terms will be 6xy to the fourth and negative 5x squared z. The coefficients are 6 and negative 5, and the variable parts are x, y to the fourth, and x squared z. All right, now we're going to evaluate some algebraic expressions. So to evaluate, we're going to plug in all the known values of the variables, then we use order of operations to determine the value. So we're going to evaluate the expression when x equals 2. And the expression is 5x to the third power. So we'll take 2 and plug it in for every instance of x. There's only one here, so we'll take 5. And I always take my substituted values and put them in parentheses when there's an exponent involved. All right, now order of operations, we'll start with the exponents. We got 5 times 2 to the third is 8, and multiply them out to get 40. Your turn, number 3. So we got 4x squared when x equals negative 3. So it's especially important when we have negative values to put them in parentheses. Because we're squaring x, that means we have to square the entire thing, negative 3. So negative 3 has to go inside the parentheses. When we square that, negative times negative is a positive, so this turns into positive 9. So we get 4 times 9, multiply them together, 36. Now in the next expression, we're going to have two variables to plug in. Four x plus 5y when x equals 8 and y equals 9. So 4 times 8 plus 5 times 9, 32 plus 45, we get 77. Your turn, number 4. So plugging those values in, 4 for x, -2 for y. Multiplying out first, order of operations, we're going to multiply first. Multiplying those out, we get -12 on the left, -8 on the right. And the last thing we're going to do is add those two things together to get -20. Next example, we're going to evaluate AB divided by -2b when a equals -6 and b equals 4. Plugging these in, we got -6 here times 4 divided by -2 times 4. Order of operations, we're going to start inside the parentheses. So that gives us -6 times 4 divided by -8. Now we've got multiplication and division across here. We're going to start working left to right. -6 times 4 is -24 divided by -8. Now negative divided by negative is a positive. 24 divided by 8 is 3, so we get 3 for that one. Your turn, number 5. -6d divided by 3c when c equals 2, and d equals -5. So let's plug in. We got -6 times d, so plug in a -5 there, divided by 3 times 2. Order of operations says inside the parentheses first. -6 times -5 divided by 6. Now we've got multiplication and division. We'll work left to right. So starting over here, -6 times -5. Negative times negative is a positive, so we get 30 divided by 6. And then finally divide to get 5. Next example, we're going to have some fractions here. And 4 different variables in this one. 3cd over 4 plus 2ab. And our values are a equals 1, b equals 5, c equals -2, and d equals 4. When we get this many variables, one of the biggest mistakes I see is people plugging in the wrong number. So you got to be careful now. So we got 3, and then c is -2, and d is 4. So there's a numerator, divide by 4, plus 2 times A, which is 1, and B, which is 5. Now notice we've got something that matches on top and the bottom, so we can cancel those out. 4 over 4 is 1, so we cancel those. So we're left with 3 times negative 2, so that's negative 6, plus 2 times 1 times 5. Now multiplication is next, so don't work left to right here, because we have addition here. Addition and subtraction is always last. We're going to multiply over here, and we get negative 6, plus 2 times 1 times 5 is 10. Add those together, and we get 4. Your turn, number 6. C squared minus 3a over b when a equals 8, b equals 2, and c equals negative 6. By plugging these in, got a negative value here, so I'm going to put that in parentheses, squared, minus 3 times a, so that's 3 times 8, over b, which is 2. Starting with the order of operations, going to start with that exponent. So negative 6 squared is positive 36. Now over here we've got the division bars are grouping symbols, so we can start up top. Consider these to be in parentheses, 3 times 8. So that's 24 over 2. Now we'll divide next, leaving subtraction for last. 36 minus 12, and then subtract to get 24. Now we're going to look at some expressions that are a little bit more complex, and keeping in mind your order of operations becomes especially important here. C minus d squared minus 5ab, when a equals negative 2, b is 3, c is negative 4, and d is 1. Plug it in. Inside the parentheses, we've got c, which is negative 4, minus 1 for d. Square that. Minus 5 times a, which is negative 2, and b, which is 3. So let's start inside this grouping symbol here. Negative 4 minus 1 is negative 5. So that gives us negative 5 squared. Minus 5 times negative 2 times 3. Next, the exponent. Negative times negative is positive, so this is positive 25. Minus 5 times negative 2 times 3. Now we're going to leave the subtraction for last. Before we do that, we're going to multiply all these out. 5 times negative 2 times 3. That's negative 30. Now subtracting a negative, that's like adding, so 25 plus 30. Add them together and we get 55. Your turn, number 7. So we've got b plus c squared minus 4ad, where a equals 2, b equals 8, c equals negative 5, and d equals negative 1. All right, let's plug these in. We've got b plus c, that's 8 plus negative 5. And we're going to square that, minus 4 times 2 times negative 1. Starting inside the parentheses, 8 plus negative 5 is 3, so that gives us 3 squared minus 4 times 2 times negative 1. Exponent is next. 3 squared, 9 minus 4 times 2 times negative 1. Now again, we're going to leave that subtraction for last. Addition and subtraction are always last. Now we'll multiply across here. 4 times 2 times negative 1. That's negative 8. Subtracting negative turns into addition, so we got 9 plus 8, add them together, and we have 17. Now some of these expressions are going to involve fractions, and if we have an expression in the numerator and the denominator, we're going to work through those separately, using order of operations on each individually. Just remember that that division bar is a grouping symbol, so what is on top and what is on bottom, you can consider them to be inside parentheses. And we're going to evaluate to get this down to a single number on the top and a single number on the bottom, and we'll either simplify the fraction or divide it out. So let's plug in 4 times c, so that's 4 times 2 minus d. So here it's really important to put the negative number inside parentheses, because now we're subtracting a negative. Never write it like this. You can't put two operations in a row like that. Got to put in parentheses. Over negative 1 times b negative 4. All right, let's look up top here. We're going to do order of operations on the top. And we've got multiplication and subtraction, so we'll start with the multiplication. So that gives us 8 minus negative 8 on top. And on the bottom, all we have is multiplication, so we might as well multiply this out. So negative 1 times negative 4 is positive 4. Right now on top, that turns into 8 plus 8 over 4. So that's 16 over 4 for the final answer. Your turn, number 8. Negative 4a over b plus c. When a equals 5, b equals 6, and c equals negative 4. So plugging these in, we got negative 4 times a, which is 5, b, which is 6, plus c, which is negative 4. Now on top of negative 1 times 4 times 5, that is negative 20. And the bottom, 6 plus negative 4 is 2. Now we've got a single number on top, single number on the bottom. Now we can divide and get negative 10. All right, now we're going to look at some expressions with a little bit more going on here. Negative of 3c minus d squared over negative 4b plus 7a. We got a equals 2, b equals 3, c equals 6, and d equals negative 4. All right, let's plug all these values in. 3 times c, so that's 6, minus d squared, so that's negative 4 squared, put that negative 4 in parentheses. And on the bottom, negative 4 times b. Okay, order of operations on top. First thing, make sure you keep that negative out front. What I usually do is I'll just write the negative, write the fraction bar so I don't forget anything. All right, exponent first. Negative 4 squared is positive 16. So we got 3 times 6 minus positive 16. And the bottom, got a multiplication here, so it's negative 12. And since it's separated by addition, we can go ahead and do those at the same time. So it's negative 12 plus 14. Now on top, next step, we've got multiplication and subtraction, so we'll do the multiplication next. So keeping that negative out front, 3 times 6 is 18, so 18 minus 16. And the bottom, we'll combine these two to get 2. Next up, finish off the top, and that is negative 1. Your turn, number 9. Two b minus 3b all over c squared minus a. When a equals 7, b equals 6, c is negative 3, and d is negative 2. So let's plug these in. 2 times b, which is 6, minus 3 times d, which is negative 2. All right, over c is negative 3, so negative 3 in parentheses, squared, minus a, which is 7. Now, order of operations on top, we got multiplication over here, so that's going to be 12, subtracting, and then we can go ahead and do this multiplication to get negative 6 on the right. And over here, negative 3 squared, that's positive 9, so 9 minus 7 on the bottom. Now the top is going to convert to addition, subtracting a negative turns into addition, so 12 plus 6 over 2 will finish off the denominator. Adding together the top, that gives us 18 over 2, or 9. Next up, we've got fractional coefficients in this one. Negative 2/3 times a squared minus 1/9 times b squared, where a equals negative 3 and b equals 6. So first thing I'm going to do is plug these in. So negative 2/3 times a squared, that's negative 3 squared, minus 1/9 times 6 squared. First thing we're going to do, order of operations, is evaluate the exponents. So we got negative 2/3 times 9 minus 1/9 times 36. Now, next thing to keep in mind is whenever you multiply a fraction by a whole number, you just multiply the whole number by the numerator. Leave the denominator alone, because this is the same as 9 over 1. So 2 times 9 is 18, so that gives us negative 18 over 3, minus 1 times 36 is 36, so 36 over 9. Next up, evaluate these fractions. They both divide evenly, so 18 divided by 3 is 6, that's negative 6, minus 36 divided by 9 is 4. Negative 6 minus 4, negative 10. Your turn, number 10. So we got negative 1/4 a squared plus 1/3 b squared, where a equals negative 2 and b equals 9. So let's plug it in. Now evaluate the exponents. Negative 2 squared is positive 4. So it's negative 1/4 times 4 plus 1/3 times 9 squared, 81. Right, now we'll multiply these. Negative 1/4 times 4, that gives us negative 4 over 4 plus 81 over 3. It's negative 1, 27. So 26 is our final answer there. Next expression. We've got negative 2/3 a minus 1/7 times bc minus ad. And we've got a equals 3, b is 6, c is 4, and d is 1. Plug it in. Negative 2/3 times 3 minus 1/7 times b times c, so that's 6 times 4, minus a times d. So let's start inside these parentheses. We're going to evaluate that. 6 times 4 is 24, minus 3. Evaluating this, you get 21. And now it looks just like the other ones. So we'll go ahead and multiply by the numerator, so that is negative 6 over 3 minus 21 times 1 on top over 7. Negative 6 over 3, that's negative 2. And negative, or subtracting, 21 over 7, which is 3. Subtract those, and we get negative 5. Your turn, number 11. One quarter a plus 3/5 times ac minus bd. And we've got a equals 4, b equals 2, c is 7, and d is negative 1. Plug all these values in. 1/4 times 4 plus 3/5 times a times c, so 4 times 7, minus b 2 times d negative 1. Starting inside the parentheses, four times 7 is 28, minus 2 times negative 1 is negative 2. You can go ahead, since we're separated by addition, I'm going to go ahead and evaluate this one. So 1/4 times 4 is 1, so we get 1, plus 3/5 times 28 plus 2. Adding those together, we get 30. So what I'm going to do now is I'm going to take this, since this is in the numerator, I'm going to go ahead and do the division first. 30 divided by 5 is 6. 6 times 3 is 18. We could have done that the way we did before by multiplying with the numerator. So 30 times 3 gives us 90. 90 divided by 5 is 18. So same answer either way. Add them together, and we get 19. So now we're back to the examples from the introduction. We're going to start off with a food stand. So we got the food stand selling pretzels and drinks. The owner created a formula for calculating total revenue in a day. And that formula is R equals revenue equals 2.5 P plus 1.25 D. Notice all the variables represent their quantities. R for revenue, P for pretzels, D for drinks. That way, when you look at the equation, you know exactly what everything means. Right now, if the owner sells 78 pretzels and 123 drinks a day, what's the total revenue? Go ahead and calculate that. So we're given that it sold 78 pretzels and 123 drinks. So that means P is 78, and D is 123. So let's plug those values in. R equals 2.5 times 78 plus 1.25 times 123. Now we'll go ahead and multiply here and here. And when we multiply that out, we get 195 plus 153, 75. Add them together. $348.75. So the total revenue is $348.75. Now in chemistry lab, we're going to be working with a very famous equation called the ideal gas equation. So here's one form of it. The other form you might see is PV equals nRT. Find that by bringing the RT over here. Now P is the pressure in atmospheres. V is the volume of the gas in liters. R, that is the ideal gas constant, in which we're going to equal to 0.08. And this constant has different values depending on which units you're using. But with the units we're using, it's going to be 0.08 rounded. And then T is the temperature in Kelvin. So now we're going to go through, find the values, and then insert them into the equation in the correct spot. All right, so as I read through this thing, I'm picking out these values here. We've got 0.475 liters, so that's the volume. So there's V. Atmospheres, there's your pressure. Temperatures in Kelvin, so there's T. And then the ideal gas constant, 0.08. So there's the values, and we're going to plug them in here and find the number of moles. So on top we have 1 times 0.475. And the bottom, 0.08 times temperature, 273.15. Now multiplying out on the top, it's just multiplying by 1, so that doesn't change the 0.475. And the bottom, 0.08 times 273.15 gives us 21.852. And now, since we're down to a single number on top, single number on the bottom, we can divide it out. And we get n equals 0.0217. And we can round that to about 0.02. So that means there are 0.02 moles of krypton gas in the sample. And that is it for today. Hope you all have a great day.